circle exam review. Secant line. Remember, a secant line goes through a circle and touches twice. So we have line AD touching it twice. So make sure if you put a line, you put the 2 points and then a line with 2 arrowheads on top. A central angle, one example, would be from A to O to B, where the vertex is the angle in the center, the central angle. So we have to put angle sign AOB. The middle letter is the vertex. Major arc has to be more than half a circle, so we could pick A, B, F. There's more than one answer to this. Put an arc on top. You have to put 3 points, and they have to go greater than half a circle. So if you follow from A to B to F, you'll see that's more than half a circle. A minor arc just needs to be less than half. So we could pick, for example, from D to F. Again, there's many different correct answers here. A chord, so from A to D was a secant line if you consider the whole line, but if you just consider the segment between A and D, no arrowheads on top, that's a chord. Point of tangency, so my tangent line is BE, right, touching it once, and that point where they touch, that is the point of tangency, so it's just B. And the tangent line, like we just said, is a line that touches it once, so that would be BE, and you got to put the arrowheads on it because it's a line. Diameter goes all the way through the circle, through the center, so A to C, it's a chord, it's a segment. Make sure you do not put arrowheads on that. Radius is halfway. We could pick B to O. BO. And the center would be the central point at O. So some of these may have more than one answer, which is fine. But these are examples of one. All right, on number 1, whenever you see these 2 tangent lines that touch once, these are congruent. So you need to set them equal. 14y minus 4 equals 8y plus 11. Let's get rid of the smaller y, so minus 8y minus 8y. 14 minus 8 is 6y. Bring down minus 4 equals 11. Alright, and then to get rid of that minus 4, we're going to add 4. So 6y equals 15. Divide that by 6. And we get 15 over 6, which reduces to 5 over 2, or 2.5. Alright. On number 2, solve for z, show your work. Same thing. If there are 2 tangent lines that intersect, they are congruent segments. 5z minus 12 equals sign 113. Get rid of the loner, adding 12 to both sides. 5z equals 125. And then you divide by 5. And you get z equals 25. Alright, number 3, if it gives you the radius of 5, then you know this r is 5, this r is 5, and this whole hypotenuse across from 90 is 5 plus 8, which is 13. Okay, so we're looking for b. Let's do the Pythagorean theorem, right? A squared plus b squared equals c squared. So we have 5 for the leg next to 90 squared, plus b is missing, the leg squared, equals the hypotenuse, which is 13, not 8, 13 squared. So 5 squared is 25. Oops. Let's get that calculator out. b squared. 13 squared is 169. Then we're going to get rid of that 25. B squared equals 169 minus 25 is 144. And then we're going to square root to get rid of the square. So B equals, square root of 144 is 12. All right. Moving on to number 4, find the measure of the following arcs. Now, before we find the arcs, we need to find the central angles. Something obvious over here, BCD, this little symbol obviously means a right angle of 90 degrees. Another thing we notice is that here's an intersection like an X, and we know that that creates these two angles, which are called vertical angles. So ACF is also 60 degrees, right? Another thing we notice, FCD is a straight line of 180, so that means that FCA and ACB together must make 90 degrees. Okay, so if I'm going to look for ACB, I'm going to do 90 minus 60 to get 30. The last angle we need to figure out is FCE. Again, if you see a straight line here, then you know DCE, if that's 60, and a straight line is 180, we're going to do 180 minus 60, and we're going to get 120. So FCE is 120. So that means all the outside arcs match the central angles. So let's look at this. DE, from D to E, must match the central angle 60, so it's 60. BFD, now that's a long way around. It's from B along the edge to F, along the edge to D. That adds up 3 separate central angles, 30 plus 60 plus 120 plus 60. And that equals 270 when we add it all up. Okay, BF adds up 2 angles, 30 and 60. Because it goes through A, that's 2 central angles. 30 plus 60, so that's going to give us 90 degrees. Okay, AB matches the central angle of 30 degrees. DEF adds up 2 central angles, 60 plus 120, and we get 180, 180 degrees. BEA adds up 4 big angles, 90 plus 60 when you're going towards B to E. And then from E to A adds 120 plus 60. So you add all that up, B to E to A, and you get 330 degrees. EF matches the central angle of 120 degrees. Alright? Down here, I want you to get used to using your yellow formula chart for circles, okay? So let's put that on the board here. While it's warming up, let's see if I can't get this to work. Nope, of course not. Alright, so this matches on our formula chart. So number 5, if you look at your formula chart, The way number 5 looks like the top left on your formula chart where the angle is on the edge, okay, as an inscribed angle. And notice the rule says angle equals 1/2 arc. And that's what we're going to use on number 5. Angle, which is C, equals 1/2, and then the arc is 56. So what's 1/2 of 56? 28. And that's it. 28 degrees. And number 6 is similar, just a little different, but you're going to set it up the same way. Angle equals half the arc. So the angle is 40. That should equal half of the arc, which is x. And how do we get rid of a 1/2? We multiply by 2. Cancel, cancel. Multiply by 2. 40 times 2 is 80. So 80 is the answer. 80 degrees. Alright. Down here, now these angles are on the inside. So again, you're looking at your formula chart, and you're wondering, where do I see angles on the inside? Right here. Okay, so the top right section, what does it say? Inside angle equals 1/2 arc plus arc. So let's do that. Inside angle is x equals 1/2, and then it's arc plus arc. 131 plus 52. You want to add those numbers together. So x equals 1/2, 183. Okay, and then we multiply, or we do a half of 183. So x should equal 91.5 degrees. And then similarly over here on number 8, central angle is y, not central, but inside angle. So y equals 1/2, arc plus arc, 93 plus 76. So we add these together. So y equals 1/2. 93 plus 76 is 169. And then half of that is 84.5. If you get a fraction, you can always hit Control-Enter and get that decimal. Alright. Next. Alright, so number 9 looks like an angle on the outside. So again, I look at my yellow sheet, try to get familiar with it. Outside angles. Oh yeah, here it is. It even says it, outside angle. Outside angle equals 1/2 big arc minus small arc. So let's do that. So the outside angle is x equals 1/2 big arc 143 minus small arc 68. So x equals 1/2. 143 minus 68 is 75. And then half of 75 is 37.5 degrees. Alright. Now it says we're solving for QRS. So I'm going to put an X for QRS. QRS. There it is. Missing angle. Now you'll notice I only have one arc, and I'm missing this arc over here. QS. The way I can figure out QS, since these are both tangent lines, there's only two arcs, and they add up to 360. So if I have 360, and I take away the one arc I know, 242, I would get 118. Okay, So that means right here I'm going to put 118. And now I can solve this the way we did before. Outside angle equals 1/2 big arc minus small arc. So outside angle is x equals 1/2 big arc 242 minus small arc 118. When I subtract those, I get 124. Alright, and then half of 124 is 62 degrees. Now these next two are the same formula. They're just going to be a little bit different the way we solve them, because x is not the outside angle, it's one of the arcs, intercepted arcs. Set it up the same way though. Angle, 43, equal sign, 1/2, big arc, 121, minus small arc, which is x. Now notice the difference between 9 and 11. Instead of the x being outside, now the x is inside the parentheses. But we'll solve this the way we did on our notes. So to get x by itself, first we get rid of that fraction 1/2 by multiplying by 2 to cancel it out. Multiplying by 2. 43 times 2 is 86 equals 121 minus x. And then to get rid of the 121, we subtract it. So 86 minus 121, 35. And that's negative 35. And that equals negative x. And remember, if you have a negative x, your last step is to divide by -1. Cancels out the negatives. So 35 equal sign x. 35 degrees. Similarly over here, so outside angle is 25, equal sign 1/2, big arc is 132, minus small arc, which is x, times 2. 50 equals 132 minus x, minus 132 gives me 82. Sorry, negative 82. And then divide by -1. 82 equals x, 82 degrees. Okay, now look at this. You see two chords, two segments inside a circle, and each part is labeled. And so you're looking at your formula chart. What would I do to do this? These are angles up at the top. We got formulas in the middle. Oh, here at the bottom we got some segments. What looks like 13? Intersecting chords, right? So you got to be really good at finding this stuff on your formula chart, and you'll be good. So intersecting chords, you're just multiplying the parts of each chord and setting them equal. So again, it's A times B equals C times D. Multiply the parts, set them equal. So similarly, x and 10 will be multiplied. So 10 times x equals sign. The other chord, 12 and 15, multiply. 12 times 15. 10 times x is 10x equals 12 times 15 gives you 180. And then to get rid of that 10 coefficient, we divide and we get 18. 18 degrees. Sorry, 18 units, I should say. Alright, and over here, same idea. Multiply two parts, so 6 times x equals sign. Multiply the parts, 4 times 9 So 6 times x is 6x, 4 times 9 is 36, and then we divide that coefficient to get 6 units. Alright, so we got to be able to find these things on our formula chart. They're all there. Alright. Next. Alright, so on this one, 15 and 16, it looks more like we have secants. We have segments that are intersecting outside of the circle. So I'm looking down here. Where do I see that? Right here. Okay, so remember, this one can be tricky. So in here it's A, which is the outside, times B, which is the whole thing. C is the outside, D is the whole thing. So it's really important that we are able to identify the whole secant segment. Okay, so first off, down here we have 9. We have 9 on the outside. And then for the whole thing, we need to add 21 plus 9, which gives me 30. Okay, so I'm going to multiply 9 and 30. On the other secant segment, we got the outside, which is 10. And then we got the whole thing with x and 10. I have to add them, not multiply. So it's x plus 10. So I'm going to multiply 10 times x plus 10. Let's do that. 10 parentheses x plus 10 equal sign, and then outside times whole thing, 9 times 30. Outside section times the whole thing, outside section times the whole thing. Let's distribute. 10 times x, 10 times 10, 10x plus, and then 10 times 10 is 100, equal sign. 9 times 30 is 270. Alright, let's solve this. Let's get rid of the loner, the constant, minus 100. So 10x equals 270 minus 100 is 170. And then we get rid of the coefficient by dividing. So 170 divided by 10 is 17 units. 16, same idea. So outside is 7, whole thing is 17 plus 7, 24. Outside is 8, whole thing is x plus 8. So let's do that. Outside is 8, whole thing is x plus 8. Equals outside is 7, whole thing is 24. Alright. Distribute. 8 times x is 8x. 8 times 8 is 64. 7 times 24 is 168. Yeah. Alright, get rid of that loner. Minus 64, minus 64. 8x equals 104. That's 104. And then to get rid of the 8, we divide. So x equals 13. Yeah. So we have 13 units for our missing variable x. Cool. Okay, on 17. So 17 says the satellite moves in a nearly circular orbit around the Earth. The radius, we got a radius of the orbit is 42,000 kilometers. Okay, at 1 p.m. the satellite is at point A. 5 p.m. the satellite is at point B. Approximately how many kilometers does the satellite travel? And it says what? Arc length. between 1 p.m. and 5 p.m. between point A and point B along the edge. What is the length of that arc? So, once again, we have a formula chart. We need to know arc length. So we need to be able to identify where that would be. So, I'm looking, I see formulas in the middle, and I see the phrase arc length, and that's what I want. So, arc length is 2 pi r theta over 360. So let's do that. So 2 times pi times r, which is 42,000, times, and then theta over 360. The angle they gave us, the central angle, is 60 over 360. Let's just plug it in. Alright, and we get 43,982.3. So those are all measured in kilometers, km. Alright. 18, the designated fishing area of a circular pond at a park is marked. So you have a part of a circular pond, or an area of a section of it. It's marked with 2 ropes attached to a buoy at the center of the pond. Each rope is 9 yards long, and together they form an angle of 170, so everything's labeled over here. What is the approximate area of the sector? Okay. So again, we're looking at our formula chart. We're looking for that phrase and found it, area of the sector. So pi r squared theta over 360. Okay, so pi r is 9, so pi 9 squared. And then theta, 170 over 360. So pi 9 squared, 170 over 360. And we get 120.166 or 120.17. yards, and this is going to be units or yards squared because we're talking about area, 2-dimensional, squared units. Alright, next. Pat kept track of her expenses. Last month she created a circle graph to show her expenses for the month. She drew a circle with a diameter of 14. So if the diameter equals 14, what's the radius equal? Half of that, so 7, right? So she divided the circle into 3 sections as shown below. What is the approximate length of the arc of the section labeled rent? Now, length of arc length, right? Just another way to say arc length. And it's for the section for rent, right over here, this arc length. So we need to figure out this central angle. So we know food is 90 degrees, because that's a right angle. Other is 126. And we need to find a rent. So we know altogether they make a whole circle of 360. So let's add up the two we know and take it away from 360. So 126 plus 90 is 216. And then 360, the whole circle. Take away the ones we know. Gives us 154. That's wrong, 144. 144. Okay, and we can label that in here, 144. So for arc length, again, we're using the formula, 2 pi r theta over 360. So it's going to be 2 times pi times 7 times 144 over 360. Times pi times 7 times 144 over 360 gives me 17.59. And remember, arc length is a length, it's one-dimensional, and we're talking about centimeters. Alright. Next part, calculate the area of a segment. Remember, you do area of a sector and a area of a triangle, and then you subtract them. Okay? To get the leftover little shaded area of the segment. So, area of a sector, again, pi r squared, theta over 360. Let's just cut to the chase, so it's going to be pi. The radius is 9 squared. Theta, my angle, for a right angle, 90 over 360. Okay. Okay, I get 63.62 centimeters squared. For the triangle, remember, if the radius down here is 9, the radius up here is also 9, which happen to be the base and the height of the triangle. Please remember that the area of a triangle is base times height divided by 2, or 1/2 base times height. So 9 times 9, don't forget to divide by 2, please. Okay, so 9 times 9 divided by 2 gives us 40.5. And then to get our final area of a segment, we need to subtract these. Okay? So, when we subtract, we get 23.12. And these are all centimeters squared. Alright. So again, you subtract that and that. Alright, let's talk about equations. Now, again, your formula chart has the equation on here. You just gotta, let's see if we can find it. So, got our formula chart, I'm looking, boom, over here. Equation of a circle. Okay. So, if I have a center and a radius, that's all I need for my equation of a circle. The center is h and k, and the radius is r. So, let's write this down. X, and then my x value says -1. Okay? Remember, inside these parentheses, it's the opposite sign. So instead of x minus 1, I'm going to write x plus 1 squared. Plus, and again, I'm just following this formula right here that we did last couple of days. Parentheses, y, and then My y value for the center is positive 7. Again, I'm going to write the opposite sign. So minus 7, parentheses squared, equals, and I'm supposed to do r squared, okay? R squared is 5 squared, which is 25. So over here I'm going to put 25. That is my answer. Okay? So remember, these are opposites inside the parentheses. Let's do it again. I got a center, I got a radius, okay? I need to know what r squared is, so 8 squared, 8 times 8, 64. So here we go. X, the opposite of a positive 3 is minus 3, parentheses squared, plus, parentheses y, the opposite of negative 8, positive plus 8, squared, equals, and we already figured this out, r squared is 64. You have to be able to write an equation. The formula is on your sheet, tells you what HK is, tells you what the radius is. Remember, inside is opposite sign, r squared, you actually have to square that radius. And let's get to graphing here. Again, same formula. I need to figure out the center, and I need to figure out the radius, okay? So, let's see here. The center is going to be the opposite of this and the opposite of this. So if this is minus 2, my center is going to be positive 2. If this is minus 3, my center is going to be positive 3. So 2 comma 3, right? So 16 is not my radius. R squared, right? The end is r squared over here. So if r squared equals 16, I'm going to square root r equals square root of 16, which is 4. So I'm going to use 2, 3, and a radius of 4. So 2 comma 3, 2 to the right, 3 up. There's my center. Okay. Let's try this again. 2, 3, put a point. Now my radius is 4, so I'm going to go 4 to the right, 4 up, 4 to the left, 4 down, and then I'm going to draw my circle to make sure it goes through those points. Okay. And over here, same idea. Okay. So the center is going to be opposite of positive 4, opposite of negative 1. So negative 4, positive 1, negative 4, positive 1. Okay. And then if r squared equals 9, square root of 9 is 3. So I'm going to go 3 to the right, 3 up, 3 left, 3 down. And then I need to draw my circle from that center through those points. Perfect. All right. And that's how you graph given the equation like we've done on the past assignments.